time to attend today's session. My name is Bharat and I'm a technical trainer with VMware working with education services. So I train internal employees of VMware and also external customers. Today's session is VRA 7 troubleshooting. Can I see the hands of you who are managing VRA 7? Who've deployed it, managing it? Yeah. Okay, so this is what we have got for you in the store. We're going to start with the components that make up VRA, and then we'll introduce you to some of the tools that you could use to troubleshoot VRA on a day-to-day basis. If not all, at least some of the key essential tools. And then we're going to see how do you track a machine request. Why is this important? Is because all VRA does is machine provisioning. We also do XAS, but because of machine provisioning failures, we're going to introduce you to the machine request tracking, and then we'll look at some of the common issues. So what are the components that make up VRA? Two major components. One is the VRA virtual appliance, which is the SUSE 11 Linux appliance, and then we've got the Windows machine for installing all the IaaS components. So on the VRA virtual appliance, we have VIDM, Virtual Identity Manager. Until version 6, we used to have a separate appliance called Identity Appliance. And we had to also depend on vSphere single sign-on for authentication. But starting version 7, we've taken the Virtual Identity Manager, the external VMware product, taken the VIDM from there, put it inside this VRA appliance. So this piece provides authentication for logging into the VRA tenant. That's VIDM. Then the next component is VCAC-server service. Very important. So this is Apache Tomcat application, which is running inside the VRA appliance. So it is a soft link, and it has got multiple VRA services tied to it. What does that mean? Once you log in into the VRA appliance, the 5480 VAMI page, you see a list of services. Most of those core services are tied to VCAC-server service. So there is no way of you restarting an individual service. Let's say you want to restart a notification or an approval service. You cannot do it. Why? Is because it is tied to VCAC-server. So you have to restart this service in order to restart all the other services. So if this service is down, pretty much all the core services on the VRA appliances are down. The next component is RabbitMQ, very important. This is the message bus. It works on the AMQP, the Advanced Messaging Queuing Protocol, and we use this pretty much on all VMware products. All it does is it goes, talks to one service, takes the message, hands it on to another service. So let's say notification service wants to talk to approval service. So RabbitMQ goes to the queue, picks it up, and hands it over to the approval service. Securely, reliable, very fast. So without RabbitMQ, the services will not communicate. The next component is vRealize Orchestrator. You can have VRO as an external appliance. We support that. But this is also embedded inside the VRA appliance itself. Fully fledged for production, you could use it. You don't need an external VRO anymore. So this is embedded inside the VRA appliance for XAS, for anything as a service. If you want to call out any third-party applications, third-party workflows, you could use VRO. And then we've got vPostgres, the internal database for the VRA appliance. So all the VIDM, the VCAC server service, and the VRO stuff. So all the content is stored inside this vPostgres database, which is embedded inside the VRA appliance. So you don't need an external database. Coming to IaaS, the first component is website. We've got so many components inside the IaaS. The first one is website. Now, this website does two major things. First one is this has access to the IaaS database. So if there is any function that requires a call to the IaaS database, this website comes into picture. And the other thing that it does is when you log in into the VRA tenant, you see different tabs, the catalog, inbox, administration, and the infrastructure. So the infrastructure tab, the contents from the infrastructure tab is provided by this website service. So most often or not, we see customers calling and saying, I go to infrastructure tab, there's a 502 error, there's a 500 internal error. And that's a symptom for the website service or the web node being down. That's website. The next one is manager. Very key piece. So all manager does is it spins off a master workflow. So when we request a machine from VRA, it is actually the manager service who is creating a master workflow. So it's a stub which is built in inside the manager server. You cannot see it. All it does is it creates the workflow saying, first you need to build the machine and then clone the machine, let's say customize the guest operating system, power it on. So all that is happening is from this manager server service. Next item is DEMS. So we have two roles. One is DEM orchestrator and DEM worker. Most often or not, the question that I get asked is, what's the difference between DEMS and proxy agents? When do we need DEMS? When do we need proxy agents? Well, DEMS are required for interacting with cloud-based endpoints. And you need proxy agents if you are interacting with hypervisor-based endpoints. Take an example, cloud-based endpoints. We support Amazon, Red Hat, Google Now, Amazon, etc. So these are all cloud-based endpoints. Now, hypervisor-based endpoints, we support vSphere, Hyper-V, Citrix-Z. So if you're talking to the hypervisor-based endpoints, we use the proxy agents. If you're using cloud-based endpoints, then we use DEMS. So the question is, if you're using hypervisor-based endpoints, do you need DEMS? Do you still need them? Or can you just not install them? Well, you still need DEMS, is because you use proxy agents for provisioning the virtual machine. Let's say there's a new machine that you're trying to deploy. It gets deployed all right if you're using proxy agents. But if you do not have DEMS, what happens is the day two operations are going to fail. What does that mean is once the machine is provisioned, let's say you want to take a snapshot or you want to delete a virtual machine. So all this comes under day two operations. So if you want to do the day two operations on the hypervisor-based endpoints, you still require DEMS. So this is absolutely required. And then we've got the IaaS database where all this information is stored, which is installed on another Windows server. We use SQL here, and that's vPostgres on the VRA appliance. Both the databases are absolutely required. So now that we've seen the components, let's talk about the tools that is going to help you in your everyday troubleshooting. First thing we recommend you doing if there is an issue is logging into the 5480, the VAMI page, and check if all the services are registered. All 38 services, and we're talking about the latest 7.3, all the 38 services must say registered. If they say failed or if they say not registered, then you may see provisioning failures. You may see authentication failures. So all services should be registered. The question is, what do you do if it is not registered? Is you use component registry. What is this? You just type this URL on the web browser, and what you type is the FQDN of your load balancer or the individual virtual appliance along with the services status current. Once you do that, it is going to show you something like this. How to make sense of it is you're looking for a service, let's say catalog service, and what's its status? If it says not available is equal to false, it means everything's okay. The service is registered, there's no problem. But if it says not available is equal to true, then we know the service is either not registered or in a failed state. Now, other thing is, if we go look, this is only going to give us 20 services. But we've got about, 38 services here, 38 services. So if you would like to view all the 38 services in one page, then you have to use this URL instead. So just change the URL from this to page 1 and limit 38. So the moment you do this, all the 38 services will get listed in the same page. So next question. What's the use of this page? Let's look at a use case. So in this case, the IaaS service says not registered. What do? We go to the component registry, look for this service IaaS, and in this case it says not available is equal to true. It means it is not registered. There's something wrong with it. And not only it says that it's not available, but also it gives you a possible cause, a reason of failure. In this case, it says remote host closed connection during handshake, a possible network failure. So the virtual appliance is not able to communicate with the IaaS node. So this way, you could just go fix the networking issue and everything should be okay. So I'm not saying it will give you the exact cause, but at least a good head start for your troubleshooting. So the moment you see any service in failed or not registered state, use component registry. First step of troubleshooting. So that is for the services in the VRA appliance. But we did talk about multiple other components. That is the website, the manager service, the DEMS agents. How are we going to monitor them is using the health URLs. So for VIDM, you must use this health URL. All you do is type the FQDN of your load balancer or individual VRA appliance, followed by this URL, and the output that you should see is something like this. All okay, yes, database status connected, and then it also tells you which is the active connector. That is, when you log in into the VRA page, you've got two appliances. Which appliance is serving the authentication request is something that you can see here. In this case, the primary appliance is serving the authentication request. The second one is VCAC-server. How do you validate this? Is you use a different URL. So in this case, VCAC-services, not hyphen, a / services API status, and you should see the word register. If you don't see this, it means VCAC-server service is down, and you should do something about it. Similarly, for IaaS web, you have a different URL, and for manager service, you have a separate URL as well. For web, you should see registered again, and for manager service, you should and absolutely should see provision service. This should be the output. If you don't see it, then your manager service is down. And for embedded vRealize orchestrator, you use this URL instead, and it should say running. And this is only for the embedded vRealize orchestrator, which is running inside the VRA appliance. If you're using an external VRO, the URL is different. It's something else. We've got more URLs. The next one is repository service, and this service is running inside the web site, the IaaS website, the first component of it. So this repository service is running inside, and the job of this one is to interact with the IaaS database. So how are you going to check if the service is all right? Is just type this URL and you should see repository entities. Don't see it? Troubleshoot it. For DEM orchestrator and DEM workers, we do not have a URL. So how are we going to validate? Is you go to tenant, you log inside the tenant, go to infrastructure, monitoring, and DEM status. You will see whether the role is orchestrator or it is worker, and whether they're online or offline. So in this case, it is online, so everything's okay. If you see a red icon instead of a green one, then you know the DEMs are offline and you need to do something about it. And about proxy agents, you just need to right-click on the compute resource and then go to proxy agents. It is going to tell you which machine. So in this case, it is using agent-dem1. If you have got multiple proxy agents installed on different servers, it is going to tell you which machine it is using to interact with the endpoints. And not just that, it is also going to tell you whether its status is all right. In this case, it is green. If it is red, then you know the proxy agent is down and you need to do something. That's health URLs. The next one is database and messaging. So before calling support, we recommend you guys check the services and check the component registry, and also do the check of the database tab. So log in into the 5480, the BAMI page, go to the database tab and ensure the database says connected. If it is not connected, then something's wrong with the database. If the database is down, as we all know, none of the services would start up. So fix the database and then all the services should come back online. So this not only tells you the state, but you can also see if the node is a master or a replica. So if you've got 3 VRA nodes, one node is going to be the master, the other 2 nodes are replica nodes. All the I/O that you're writing to the database is getting written to the primary appliance, and it is being synced with the replica nodes. So you can see which is a master node from here. The next one is messaging. This is about RabbitMQ. So RabbitMQ, what it does is takes the message from one service, passes it on to the other service. So if it is down, in this case it is running. If it is not running, then none of the services would start. Everything will say not registered or failed. So database and messaging, both should be connected running. If not, your services are going to fail. The other key thing I would like to highlight is when the RabbitMQ communicates with the VRA nodes, it is going to use the short name, not the FQDN. This is by design in version 7. So in your environment, if you guys do not have your short name resolution working as expected, what does that mean? NSLOOKUP VRA1 doesn't give you what you're looking for. NSLOOKUP VRA2 doesn't work. Then RabbitMQ will just go poof. Rest in peace. Doesn't work. Because by default, it uses VRA1, the short name, not the FQDN. There is a way of changing this to FQDN if you would like. Just go Google it, and then you can find the steps. You just have to stop the service, edit a config file, and then you could use the FQDN instead. But make sure your short name resolution is working. And what else can you do is, we've looked at the database tab, messaging tab, now we're looking at the cluster tab. What this does is, it is going to tell you whether this node, this VRA appliance is in a cluster format or not. So we did say if there are multiple VRA appliances, all these 3 form a cluster. So whether it is in a cluster mode or not is something that you can see here. And you can also see the last connected. We know that VRA has multiple components, and in a distributed setup, all these components are installed on several different machines. How do we ensure their connectivity is okay? Is just by looking here. So in this case, all the other nodes have last connected a very recent time, except for just one node that is agent-dem2, which has got 6 days. So by this, you know there's something wrong with just this node. So just go find out what's going on. So if you're just wondering how is it that the virtual appliance is able to get this information, how is it that we're able to see this in the VRA appliance, is at the time of deployment, you would install something called as management agent on all the IaaS nodes. So the VRA appliance is going to talk to the management agents to pull this information. So if your network is down, if your management agent service is down, then you're going to see a big number against last connected. And the next thing to look for is time difference. We all recommend all VRA nodes must be in sync with the same NTP server. If it is not, if you've got a time drift, then your provisioning would fail. So it should be as minimum as possible. If you see a big number against time drift, time offset, then go ahead and troubleshoot the time difference on that particular node. So you've done all this, then you say you're at the point where you say, I give up. I cannot do this anymore myself. What you do, very simple. Just go and say, create support bundle. Collect the bundle, then create a case with GSS. If you guys have worked in version 6.x, it's a pain to collect log bundles in version 6. So you had to go to individual nodes, collect the log file from all of these individually, log in into all of these machines individually, get the logs, zip it, and send it to GSS. Now in version 7, there is this option. Just click on it. It is going to talk to all the nodes and collect all the log files from there. So for this to work, your management agent service on the IaaS nodes must be running. If it is not running, then we're not going to collect the logs from that node. So now we're going to talk about maintenance. You're at a stage, let's say GSS says, might you have to reboot your infrastructure because you just applied a patch or whatnot, you have to reboot your VRA infrastructure. Or let's say coming Sunday, there's a maintenance that is scheduled in your environment. How are you going to reboot your VRA distributed setup? So first thing to do is you disable the secondary nodes and the health monitors. How you do this is you have to log in into the load balancer. You're using NSX, F5, the two most commonly used. So you log in into the load balancer, you disable the secondary nodes, and you also have to disable the health monitors. And then you need to start shutting down your secondary nodes. And then you have to follow the proper startup and shutdown order. What is the order? We'll discuss in the next slide. And once that is done, you have to power on your primary nodes. You might ask why. It's because at the time of shutdown, we had shut down the secondary nodes on the load balancer and only the primary nodes are online. So at the time of rebooting, you have to bring your primary nodes first so you can talk to the load balancer, bring all the services back online. And once it is online, you can go ahead and re-enable the secondary nodes and re-enable the health monitors. If you fail to follow this procedure, you just reboot it, none of the services are going to come online. Everything will say failed. And this is one of the most common issues seen in GSS. Customer says, I had a scheduled maintenance, I just rebooted my environment, but the services are not coming up. Well, it wouldn't. Why? Because you have to follow this procedure. So what is the startup order? What is the shutdown order? Let's take a look. How to shut it down? This is the order. You must first shut down your proxy agents, followed by DEMS, manager, website, and then the VRA appliance. And then what you do is shut down the SQL node. This is the IaaS database. And then finally, you shut down your load balancer. What is the startup order then? Anyone? What's the startup order? Exactly opposite, right? So you bring your load balancer first, then your SQL database, followed by the virtual appliance, the website, manager, and then DEMS, proxy agents. This is the startup order. You might as well ask, how do I remember this stuff? You don't have to. So this is going with the order of installation. So if you look at the installation order, we first set up the load balancer, then get your database online, and then we start with the VRA appliance all the way, web, manager, in the same order. So your startup and shutdown is in the same order of installation. Okay? I'm excited about this. Version 7.3. How many of you here are using 7.3? Just two? Just two? This might be a good reason for you to update or upgrade. So let's see, in 7.3, well, let's talk about pre-7.3 first. So until version 7.1 or 7.2, we had this tool called VRPT, vRealize Production Test. So you had to go to the VMware Download Center and download this tool and then connect this tool to the VRA infrastructure. What it used to do is run a bunch of tests and give you the results whether your environment is okay or not. So with version 7.3, what we've done, well, why do we have to download it externally? Why not inside the VRA appliance? So that is exactly what we've done. It is now built in inside the VRA appliance. So you log in into the tenant, go to administration, and you can find the option down at the bottom, help. Click on it, and you have to say new configuration. The moment you do that, it is going to ask you, what do you want? You want to monitor VRA 7.3 or you want to monitor the embedded vRealize orchestrator? Two options. In this case, I've selected VRA 7.3, and there's also an option, how often would you like this to run? 15 minutes, 30 minutes, 1 hour. Select what you want, and then you go next. There are two things that this tool does. One is system check, the other one is tenant check. System check, for example, whether your license is expired or not, whether all the services are running or not, that's system check. Tenant check, are your endpoints okay? Are your compute resources, are your reservations? Well, the main thing it does is your reservation, whether it is running out of CPU, memory, and hard disk. So that is what we're going to check in tenant test. So you select what you want, you go next, you just type the address, the password for the vRealize appliance. You click on save, and it's going to give you this screen. You just have to click on run. The moment you do that, it's going to give you this icon, the green circle. Click on that green circle. What you see is this. So it is going to tell you whether the result passed or failed. And we have segregated the results based on severity. The highest severity is blocker. And in this case, we have highlighted 2, that is blocker. So you can see it verifies the vRealize license. Well, if your license is expired, nothing works, right? So we've put that under blocker. So based on the severity, we've segregated blocker, critical, or just information. So in the other case, critical, we're saying there is an approval service that is registered. So if it is down, that's critical. Is there a way of having this tool to send emails automatically? Well, not as yet. So you just have to run this report manually and then review the results manually. If something's wrong, there's no way of sending emails as of yet. We've taken that as a future request. Next thing is upgrade assist tool. Now, one more question. How many of you are on 6.x? vRealize 6.x. Please upgrade to version 7. Humble request. So if you need help with the upgrade, we've got this tool. Just like we discussed about the BRPT tool, similarly, you just go to VMware Download Center and download this upgrade tool. You run this on a 6.x environment. What it does, it talks to your vRealize environment. It is going to tell you how safely can you upgrade your 6.x to 7.x. Because there are a lot of changes that we brought in version 7. The biggest change is application services or application directive. Where we used to do software as a service on a separate appliance is now inside the vRealize appliance itself. So are we going to let you do upgrade to version 7 seamlessly, or is it going to be a blocker for you, is something that this report is going to tell. And if you need help analyzing this report, there is a link to the KB. So review that KB. It is going to tell you how seamlessly can you upgrade your environment. If you still need help, don't worry. Just run this report and then collect the diagnostic information, upload it to GSS. An engineer is going to call you back and he's going to help you upgrade your environment to version 7. Okay? Right. Now, tracking machine request. Why is this important? Is because a lot of issues, a lot of cases seen by GSS is based on provisioning failures. So for us to be able to troubleshoot a provisioning failure, you need to understand how does the request work. What does that mean? Is when you log in into the vRealize tenant, go to the catalog tab, and you click on request for a machine. We've got so many vRealize components. How is it going to interact with all these various components to bring the final result? Let's take a look. So I, as a user, I log in into the vRealize tenant, I type my username, password, I then go to the self-service catalog, that is the catalog tab, and then I click on my machine that I would like to request, and I say request. Now, when this form loads, what is it? The request form. What it is what's the amount of CPU, what's the amount of memory disk that is going to be assigned to you. That's the request form. So before you hit on request, you get that form. Where is it getting loaded from is the repository service, which is on the IaaS website. So if your website is down, then users cannot get to that page where it loads that request form. Now once you get that form, you say request for a virtual machine, then you're going to see a binding ID getting created by the vRealize appliance. Why is this important? Is because the vRealize appliance is a SUSE Linux. We've got all the IaaS components on Windows based. So how are they going to interact with each other? Is by using this vRealize binding ID. So the ID is created by the vRealize appliance, and it uses this to track the request all the way through all the components of IaaS. And then if you have set up approvals, let's say a user is requesting a machine over 4 gigs and you want that request to get approval from the manager. So you've set that approval, we're going to talk to the notification service, get the required approvals, and then the WAPI service, which is inside the IaaS website, is going to do the required conversion. So until here, the request is still with the VRA appliance, then it goes to the IaaS web node. Inside that node, there is a WAPI service. What it does, takes the Linux-based request, converts it into the JSON format, and then hands it off to the repository, who has access to the IaaS database. And what repository does is it is going to talk to the endpoints, and it is going to tell whether you have enough resources in the reservation or not. Because we do not want to go all the way until all the components and then come back and tell you, oops, there's no reservation. We cannot provision the virtual machine. So we are going to do that pre-check before we start the machine provisioning. So if you do not have enough resources, we're going to fail right here, instantly. We're not going to go to the next stage. So if that passes, then we're going to then give the request to the manager service, who is then going to start a master workflow. It is the manager service who is responsible for creating this workflow, starting from building machine to cloning, powering on, etc., etc. All the other components, right until here, they're only responsible for validating your request and only validating. The actual machine provisioning is going to start at the manager service. And then based on the type of endpoints you have, if you have a proxy endpoint that is your hypervisor-based endpoint, we're going to hand off the request to proxy agents. If it is a cloud-based endpoint, we're going to hand off the request to the DEMS. And then it is the job of these two components to interact with your endpoints and get your workflows executed. And finally, you will see your virtual machine in the items tab. Next up, we'll look at the common issue. The most common issue seen by GSS, like I mentioned, is on provisioning failure. Customer calls and just says, my provisioning is failing. And there's only 2 states. That is, one is it fails instantly or it stays in progress. These are the only 2 states. So what we're saying is, if the machine request fails instantly, then the issue is always and always with these 2 components. That is the VRA virtual appliance and the IaaS web. Why? Is because only until this stage we're doing all the validation required. Once it passes this stage, it is the job of manager, DEMS, and proxy agents to start provisioning the virtual machine and then hand it off to you. So if it stays in progress for a long time, it does not make sense to look at the VRA virtual appliance or the IaaS website. So you must always and always look at the manager service, DEMS, and the proxy agents. All that is fine. How are we going to track the machine request through the logs? Is by using the context ID and the work item ID. So let's see an example. So in this case, we've got a failure. So I've got a SLES 11 virtual machine that I'm trying to request, and it says failed. What am I going to do about it? Just take this blueprint name or the request ID, go to the log inside the VRA appliance. It's called the Catalina out.log. Go to that log and grep or search using either the item name or the request number. As soon as you do that, you get something called as context ID. This is unique per request. So if you're, let's say, doing 10 different requests, each request will get a unique context ID. And this ID is going to remain unique and consistent throughout all the VRA components, which means you look at it from the VRA appliance, you go to any IaaS node, you're going to see the same context ID. So take this context ID, in this case, it says the request has been submitted. So let's go to the next location, we'll look at the manager.log. So in the manager log, you can see the same context ID, what we saw before this. Let me go back. So that's the ID ending with S4G, and you see the same ID over there, S4G. It's the same request that we see in the manager one as well. What manager does is it is going to start provisioning the virtual machine. Well, for us it is just a VM, but for manager service there are sub workflows. What do I mean? I was saying that manager service is going to go through different phases of machine building, right from requested, waiting to build, building machine, clone, and then power on. So each state is a separate workflow for the manager service. So it is going to take this workflow and then hand it over to proxy agents or DEMs. So each workflow that it is going to create will have a unique work item ID. And that is what we have highlighted here, work item ID. So each work item has a unique ID. It is going to take this and then hand it over to the next, that is the DEMs and the proxy agents. So now you have to go to the DEM log and then look for the work item ID. The beauty of this is, instead of saying, well, my virtual machine provisioning failed, well, I don't know why. Instead, just go look at the logs. Now I can exactly tell, did it fail at the time of building the machine, or while cloning the machine, or while powering on? So that is where the work item ID comes into picture. And the next issue, well, before we get there, login site. VRA integrates with login site, absolutely brilliant. So what I have done is, I've just logged in. This is the login site screen that you're seeing. So you just go to login site and say, when did the virtual machine request fail? In my case, it just failed the past hour. You can just say past day. And I have used the context ID, and the keyword to look for is provisioning failed with details. The moment you do this, and you say enter, login site is going to give you the exact error message why the provisioning failed. So in this case, you can see the error message. It says does not exist, provisioning may fail, the blueprint is updated. So it's going to give you the exact error message. So you may wonder, I don't have login site. What do I do? Is you go to the catalina.out log, which is inside the VRA appliance, and then you look for the same keyword, the same context ID, and the same keyword provisioning failed with details, and you're going to get to the same error message. So all login site is doing is going to the appliance, getting the logs from there. So either you do it this way or do the manual way, you're going to get the same result. And if you have set up a VRA 7 distributed node, then by default, the identity provider is going to assume your primary VRA appliance as the default name or the FQDN. What it means is, these are the two connectors, the two VRA appliances, and when you are going to log in into the VRA tenant, it is going to use this host name, which means if your primary appliance goes down, then you cannot log in into the VRA tenant. So what do we do is you ensure that you replace the primary appliance with the load balancer FQDN. So this is by default. So I request you guys to go back, if you are managing version 7 distributed setup, just go take a look at the connectors, ensure that the IDP host name is the fully qualified domain name of your load balancer and not the individual VRA appliances. Some of the useful links, log location, build numbers of different VRA versions, link to your VRPT tool, and the release notes. So with that, we come to the end. Well, if this is something new that we've gone to the online badging. Before this, we were handing out badges manually. Now, if you get certified, these are e-badges. If you need more information on this, talk to one of us here. We're going to help you out. And if you want to do certification, today's the last day, the right day. We've got some discounts for certification, and the track is CMA for vRealize automation certification, cloud management and automation. So with that, time for Q&A, if you've got any. Otherwise, thank you very much for your time. Nice meeting you all.